Okay, students, we're going to work out the back side of the trig worksheet now. Number 11, find the area of the triangle to the nearest hundredth. Okay, so we're given two sides and the included angle. There's a formula called the law of cosines that you can memorize. That will get it a little bit quicker, but to me, instead of having to memorize another formula, it's easiest just to draw myself a right triangle, draw the altitude, remember it's called the altitude or the height, right there. And we know the area formula for area of a triangle is 1/2 base times the height. Okay. So notice it says B is 8. So we know what the base is right now. So we can even fill that in. 1/2, the base is 8. And now we got to calculate the height. It tells me theta here is 35 and A is 4. Okay. So that means this is 55 degrees up here. So we want to use, if we want to use the 35-degree angle, and that's the opposite, and that's the hypotenuse, which is sine. So the sine of 35 equals the opposite, which is the height, over the hypotenuse, which is 4. Cross multiply, I get the height equals 4 sine 35. That's the exact answer. So now I'm going to take that and plug it into the height right there. See, the height goes right there. So 4 sine 35. Now I'm going to put all that in a calculator. I could, if I want to, simplify myself. 1/2 is 4 times 4 is 16 sine 35 then. Okay, and that's the exact answer. But notice we want nearest hundredth. So that means put in the calculator. A is approximately equal to, let's bring up the graphing calculator here. Come on. Are you kidding me? I guess I'm going to put that down maybe. Okay. Bring the graphing calculator. Clear, and what was it, 16 sine 35? Yes, 16 sine 35. Now don't forget, we got to change our mode. We open it up again for the first time, so to change to degrees mode. Enter 16 sine 35, and that is 9.2. Oops, wrong one. Let's the other worksheet. 16 sine 35 is so the total area is 9 point, what was it, 9.2, what was it again? 9 point, oh, we are nearest hundredth, so 9.18. 9.18 square units. So you use squared. We don't know what the units are, so you use squared. Remember, area is always squared. Okay, so there's number 11. All right, number 12. Let's go ahead and change the color. Go to blue this time. If theta is an acute angle, so what's acute? Between 0 and 90. So I draw a quadrant. Remember, quadrant 1 is between 0 and 90. So I draw a right triangle like this in quadrant 1. Remember, that's 0 degrees, and that's 90 degrees. Positive degrees is counterclockwise. Theta is always this angle every time. Okay. This is called the terminal side. Just so you know, terminal side, because that's where it ends or stops. So the theta is between the terminal side and the x-axis always. Okay. So it says sine, which we know is opposite over hypotenuse. So the opposite, 5 over the hypotenuse, 13. And then you should recognize that's a 5, 12, 13 Pythagorean triple. If not, you have to work out Pythagorean theorem to come up with your 12 there. Huge advantage for those that memorize it. Okay, because now you can get right to the answer. It says, now what's the tangent of theta? So we're at that same angle. Tangent, remember, is opposite over adjacent. We've already identified opposite right there, hypotenuse right there, and there's the adjacent. So the opposite, 5, over the adjacent, 12. And there's my answer. So if you know your Pythagorean triples, you'll be able to do this much quicker. Okay. Now, just so you know, if I want to throw a trick question there, I said, what's the tangent of 90 minus theta? Well, where's 90 minus theta? That's the other angle right there, right? Because these two are complementary. So if that's theta, the other one is 90 minus theta. And then I'd be doing the tangent from there, which would be opposite or hypotenuse, would be 12/5. Okay, so just know theta and then the opposite acute angle, because two angles add to 90. Because if I take theta plus 90 minus theta, notice the thetas cancel out and you get 90 degrees, just like two complementary angles are supposed to be. Okay, so there's 5/12. So I'm going to go ahead and erase that. You can pause it if you want and write it down. I'm doing it again. Notice all these 13, 14, 15, acute angle. So again, I'm drawing the same thing, quadrant 1. Same type of triangle every time. Right triangle, theta is always there between the terminal side and the x-axis. So sine is 7/25, opposite or hypotenuse. We should know that's a 7, 24, 25 Pythagorean triple. If not, you're going to have to work out Pythagorean theorem. Now it says find the tangent of that one. Tangent again is opposite over adjacent. So opposite over adjacent makes it 7/24. Okay, so there's the answer, 7/24. Now, how do you know to leave it as a fraction? Because it says sine of theta, they give it to you as a fraction right there. So as the tangent of theta, they want it as a fraction. Okay, if they had given this to me as a decimal, I would need to convert it to a fraction in order to put my two side lengths on for sine opposite over hypotenuse. But then that would tell me to give you the answer back. So if they said 0.28, that's what 7/25 is, then I would go ahead and convert that to a fraction, which is 7/25. So I could put in those numbers, 725, and then I know it was 24. But if they give it to me as the decimal, then I know I wouldn't leave this as an answer of 7/24, so I would convert that to a decimal, since if they had given to me that as a decimal. I'm not doing that, they're all fractions. Okay, I'm just throwing that out there in case you were to see something like that. Okay, that was 12 and 13, so we're on 14 now. Okay. Acute angle, again, quadrant 1. It's all you're going to deal with is quadrant 1s right now. For the end of the year, we have extra time and we're going to more with trig, unit circle stuff, then I teach you the other stuff more. This time it says tangent. What's tangent? Opposite over adjacent. So it says the opposite side is 8 and the adjacent side is 15. Of course, then I know my Pythagorean triples, and I have an 8, 15, 17 Pythagorean triple. And now it says find the cosine of theta. I know cosine from SOHCAHTOA is A over H. Okay, you better know how to spell SOHCAHTOA correctly. So cosine is A over H, adjacent over hypotenuse. Again, if you can't identify the sides correctly, you're gone. So adjacent, 15/17 would be my answer. Okay, you're always going to give me answers in fractions when you see this, because I give it to you a fraction here. All right, one more of these, 15. This time they say the acute angle, which means again quadrant 1, 0 to 90 degrees. Theta is always between the terminal side and the x-axis. The cosine, which is adjacent over hypotenuse. There's my hypotenuse, adjacent and opposite. Adjacent is 8/17. That makes this 15, 8, 15, 17 Pythagorean triple. Now find the sine. Sine we know is opposite over hypotenuse. The opposite is 15, hypotenuse 17. So 15/17 would be my answer. I forgot to leave you a blank on this one. Okay, to write it in, 15/17. Okay, number 16. Yeah, okay. I don't think I missed anything up there. No, we already did that, 11. So 16, notice is the same type. So you're just getting two practice problems on it. Just like I gave you few on the 4 there on 12 to 15. Okay, so I draw my right triangle again. I'm going to have to find the height. They tell me the theta is 39. They tell me A is 8. And tell me B is 8. Okay. All right. So how to find that? I need the opposite over the hypotenuse. Sine again. So the sine of 39 equals the opposite, h over the hypotenuse, 8. Cross multiply, h equals 8 sine 39. That's the height. Remember, the area of a triangle is 1/2 the base, which is 8, times the height, which is 8 sine 39. So 4 times 8 is 32 sine 39 is the exact area. But we want the approximate area to the nearest hundredth. So now I plug in 32 sine 39. 32 sine 39. That gives me 20.14 round to the nearest hundredth. 20.14 and then square units since they don't tell me what the units are. There's my answer. Again, you lose a point if you forget the units. You don't round correctly, you lose a point. Okay, so make sure you don't blow it on those. All right, 18. Find the measure of angle A. Well, here's angle A, so that's where my theta, that's what I'm looking for. And then here's my given information right here. B, little b is 7. We know to put that across from big B. Remember, side lengths are lowercase. Little c is across from big C. Okay, and this would be little a. Okay, it tells you it's not drawn to scale. That's how it'll say on the SATs as well. So the two sides are given to us in regards to that theta there is the adjacent side and the hypotenuse. So what is A and H? That's cosine. So I have a cosine of theta, or I can just say angle A, same thing, equals adjacent 7 over the hypotenuse 16. Remember, we're solving for angle A, so I have to get rid of cosine, and that's by inverse cosine. We've already done this in class. So angle A, and we're going to the nearest tenth. The exact answer would be inverse cosine of 7/16. Now we type that in the calculator. Inverse cosine of 7/16. Second cosine for inverse cosine of 7 divided by 16. And that answer is 64.1. We're going to the nearest tenth, 64.1 degrees. So A is approximately 64.1 degrees. Okay, 17. You're standing 15 meters from a tree. So you got this tree right here. Okay, you're standing 15 meters from it. Your eye level is 1.5. So here's your eyes right here, 1.5 meters above the ground. You're looking to the top of the tree. So the angle of elevation is 63 degrees. So when I go straight across right here, this is 63 degrees. Angle of elevation. Remember, angle of elevation is the same as the angle of depression. Angle of depression would be that angle right there, because these are parallel lines cut by a transversal, therefore alternate interior angles are equal. So angle of depression, angle of elevation are the same degree, just so you know. You're likely to have one or the other, either an angle of depression, which is number 19, or an angle of elevation, like this one, number 17 on the DCAS. So make sure you know how to do these problems. Okay, so don't forget this right here is 1.5 meters after we find whatever this length is right here. This height would add on the 1.5 that we're standing up at. Okay, so we're looking for this height right here from eye level up. We have 63 degrees, and we have this is 15 right here because we're 15 feet away from the base of the tree. So I have opposite. Let's change the color here. Come on. The opposite side and the adjacent side, because here's my hypotenuse. So opposite over adjacent is tangent. So the tangent of 63, remember next to the trig function is always an angle measure. The opposite is h over the adjacent is 15. Cross multiply and you get h equals 15 tan 63. Very easy. That's the exact answer, but we're going to the nearest tenth. So now I put in 15 tan 63 in the calculator. 15, 10, 63 on the calculator, 29.4. So this H right here is 29.4, but then I have to add on the 1.5 on how tall I am, where my eyes are, and that gives me 0.9 and 30.9, and what is the units? Meter. So 30.9 meters is the height of the tree. Okay, all these types of problems you have in your test. Okay, so you got an example of every type. No excuse for not getting anything right, because you can watch the video over and over. Make sure you have it memorized down. Okay, let's go ahead and erase all that. A line makes an angle of depression. So here's this angle of depression, remember, is right here, 49 degrees. Well, that means that's the same as the angle of elevation down here, 49 degrees, because parallel lines cut by a transversal alternate interior angles are congruent. Okay, it says find the slope. What do we know slope is? Change in y right here over the change in x right here. Okay, that's what slope is. So if I'm going to use this angle now, because I can bring this 49 down to here because of alternate interior angles, what is this side called? This is the opposite side, and this is the adjacent side. Okay, so tangent then. Tangent of 49 degrees is what the slope is. Change y over change in x. Now, that tangent is going to give you a positive answer. We know it's going down, so we have to add a negative in front for negative tangent 49 because the slope is going down. It goes down to the right, it's a negative slope. So you automatically know it's a negative answer, and then, of course, that makes sense when you talk about depression. Okay, depression is down, so negative tan 49. Negative button, tan 49. Negative 1.15. Okay, it's going to thousands, so let me look what it was. Negative 1.150 to the thousandth spot. Okay, there's my slope right there. The nearest thousandths. Make sure you go back and read the directions every time. Okay, so that's the back page of the trig worksheet. Okay, that will do it. Where's my, there we go.